Terry. Thanks for that great introduction. It's been really fun to get to know you these past few years, especially as we started to work together more closely on ClinGen. And it's so nice to see many of you today. I even bumped into one of my colleagues who I didn't expect to see here. I didn't know I had to travel to Hawaii to see Jonathan Haynes, but it was really nice to see you this morning. He shares a birthday with my daughter. Every year I email him and I say, hey, happy birthday, and I send him a picture. And I happened to bring my daughter with me, so they were able to meet this morning, which was a real treat for me. So for those of you that aren't familiar, I know some of you are grantees of NHGRI, but I did want to take some time this morning to give you an overview of our Division of Genomic Medicine, and then spend a little bit of time just touching on a couple of genomic medicine data resources. You've heard a bit about ClinGen. We do have a workshop later, but for those of you that can't make it, I'll just say a few things about ClinGen and a few other resources, and then introduce a new program that we're just about to kick off in Multiomics for Health and Disease. So NHGRI has 3 extramural funding divisions. There's a division of genome sciences. You may be familiar with programs like ENCODE, or the newer program investigating genomic variation and function, or the Centers of Excellence in Genome Sciences. Those programs are funded by our Division of Genomic Sciences. And then we have our Division of Genomics and Society, which is where our LC research program comes from. And then last but not least is our Division of Genomic Medicine, which is where I've been working the past 10 years or so. And our high-level mission is promoting the Institute's efforts to advance the application of genomics to medical science and clinical care. We have been spending much of the last few years thinking about how best to implement some of the good ideas that were put forward in our strategic vision for improving genomic health at the forefront of genomic medicine. If you haven't had a chance to read through the strategic vision, I encourage you to do that. And we do this in a couple of different ways. We oversee research programs, both big consortia that we lead, many of you are familiar with, and then we have portfolios of investigator-initiated research. We are invested in training programs, and then we continue to hold meetings and workshops, and this is a way to hear from all of you to understand what are some of the gaps and opportunities and think about how we want to move forward, especially in thinking about getting genomic medicine to the point where it's serving our entire population. So this is my Division of Genomic Medicine team, where I like to think small but mighty. We have about 10 program directors and a number of other staff that run many of the programs that you've heard about already today. And just to give you a sense of what our funding looks like in our division, so when I came to the NIH actually 15 years ago, and we were in the Office of Population Genomics. The Office of Population Genomics is where we launched some of the first genome-wide association studies, like the Genetic Association Information Network, if you remember that, or the Genes, Environment, and Health Initiative, GEI in Geneva. And then about in 2011, we switched over to the Division of Genomic Medicine when we really thought it was time to take some of what we were learning in the Office of Population Genomics and try to think about how we can push the field forward into integrating genetic variation into clinical care. So our budget started out pretty modestly back in 2011, and it's grown quite a bit in the past 10 years. So in fiscal 2021, we were up to about $75 million a year. I don't have the most recent fiscal 22 budget. It takes a while to close out the books, but we were roughly about the same funding level. Some of you may have seen that the President finally signed the bill, so we have a budget for fiscal 2023, which is exciting news for us. There's about a 5% increase across all of the NIH, which is also good news. Some of those funds, though, will go to specific projects. There's a big push for more work in Alzheimer's disease, for example. So it's not that each institute will see a 5% increase, but probably something between 3.5% to 4%, depending on where some of those specific project funds go. So we're happy that we will have some increase in money to distribute to all of our grantees in the next year. One other point to make here, I don't have it shown on the slide, but about 25% of our research in our division is investigator-initiated. We do manage a lot of large consortia, but one of our goals is really to push to fund more investigator-initiated research. So we're hoping to receive applications from many of you, and I'll point out a few funding opportunities here in a moment. So here, just giving you a sense of where our money in fiscal year 21 goes. Again, the majority of the funds support our large consortia. We've talked about many of them today. We've heard about CSER, which is generating evidence of clinical utility in diverse clinical settings. We've heard about eMERGE, and now PRIMED, which are really improving the application of PRS, and PRIMED in particular in diverse populations. The Undiagnosed Disease Network, I don't know if I've heard that brought up yet today, but this is a program that expanded on the NIH's Undiagnosed Disease program that was at the Clinical Center. It was quite successful as a common fund program over the past 10 years, and it's really advanced the field in approaches for diagnosing rare diseases. And I did notice in the new budget for 2023, there are additional funds set aside for the Undiagnosed Disease program as well. I won't say much about training today. We do have a couple of my colleagues focus specifically on training. We've got genomic medicine training grants. We've got other career development opportunities. But what really we've been working on in the past year or so is coordinating the training efforts across the NIH. We have a new Training, Diversity, and Health Equity Office, which is led by my colleague, Vince Bonham. You heard a quote from him earlier today. The mission of TIDE is to not only to coordinate, develop, and support training programs for genomic careers, but also to develop and support initiatives to enhance genomic workforce diversity and genomic health equity. We have a new funding opportunity on the street. If you haven't seen it yet, it's Diversity Genomic Centers, and the idea is to establish these new large genomic research centers at minority-serving institutions. The application for that program is due, I think, in early June. And then providing strategic programmatic leadership for training, diversity, and health equity at NHGRI and across the NIH, really. And then I wanted to say a little bit more about my comment that we are really trying to encourage investigator-initiated applications at NHGRI in our Division of Genomic Medicine. So we have a funding opportunity that's on, still open, called Advancing Genomic Medicine Research. And the idea here isn't, unlike the other programs which are cooperative agreements, this is really to solicit applications from R21 and R01 grants with the idea of stimulating innovation and to advance our understanding of where, when, and how to best implement the use of genomic medicine, information, and technologies in clinical care. What we really want to see in these applications are that they're broadly applicable, not necessarily focused on a single disease, otherwise that would be better served at another NIH institute. And then that there's a focus on including ancestrally diverse and underrepresented populations in these in applications. So the next receipt date for this opportunity is March 13th, and there'll be another receipt date in 2024. If you have any questions about this, you're interested, my colleague Christine Chang at NHGRI would be happy to talk with you. Another, I mentioned that we organize a lot of workshops at NHGRI. I think it's a really nice opportunity for us to convene experts in the field. One of our more recent workshops was in clinical informatics, where the idea was to establish a research agenda, thinking about where we want to move the field in the coming years. And one of the outputs of that meeting was the idea that we'd really like to see more tools and approaches to enhance the patient's use of genomic information. So we have a notice of special interest that's available. It doesn't expire for a few more years. And the idea is we want to stimulate all of you to submit applications where we're thinking about how can we securely develop approaches to help patients securely share their genomic results and associated health data, remaining engaged with genomic information over their lifetime, learning about their genomic health, engaging with their information across multiple platforms, and then also improving shared decision-making with their providers. So these are some of the areas where we see from our division are real opportunities to develop new approaches. And again, we're trying to stimulate the field in that direction. So I'll just take a few moments to provide an overview of a couple of resources that I think are near and dear to my heart and probably yours as well. We've heard a lot about the GEOS Catalog. I should say that our division, we support resources both that cover common variation for complex disease like the GEOS Catalog, and then rare variation for Mendelian diseases like ClinGen. And a couple of years ago, I wouldn't have thought to put the GEOS Catalog on a slide that's talking about genomic medicine data resources, but it's become clear that, as we heard in the presentations earlier today, that the GEOS Catalog has become a really important resource for aggregate information that's used now in PRS score development, and we're seeing those PRS moved into the clinical setting. This is actually meant to just show, this is looking back 10 years. Dana Crawford had a slide like this yesterday morning as well. But this is where we were 10 years ago with the GEOS Catalog. And you can see now we've pretty much filled out every single spot on all our chromosomes. We've got over 6,000 publications and almost 500,000 statistically significant associations. And then just to say a little bit about ClinGen, and then lastly, the Phoenix Toolkit is another resource I want to mention. So ClinGen's mission is building and supporting this authoritative central resource that defines the clinical relevance of genes and variants for use in precision medicine and research. We have a few of our ClinGen PIs here today, Sharon Flan, Alex Milosavljevic, and Terry Klein. They work together for the Baylor and Stanford team. Heidi Ream is here, and you'll be hearing from her in a moment, and Krista Martin and Erin Riggs are the Broad-Geisinger team, and Jonathan Berg from UNC. We're really grateful. We have a lot of support now across the NIH for ClinGen. ClinGen, although it's 3 grants, has grown into a very large consortium of over 2,000 individuals contributing to ClinGen from 59 different countries around the world. It's really a global network at this point. We've got nearly 40 working groups and over 100 expert panels, and the expert panels are those that are doing the work in curating the clinical variants. So this is the ClinGen infographic that just gives you a high-level overview of key activities. So starting at the top, aggregating genomic and health data is critically important. Heidi Ream and her team have done a lot of work in this space. And then once we have that aggregate genomic and health data, we use it to then ask critical questions and do the curation around gene disease validity, variant pathogenicity, dosage sensitivity, and clinical actionability. And then, of course, disseminate this expert curated knowledge and continue to evaluate and improve ClinGen's standard frameworks and approaches. So I'll just say a word about, we often hear about ClinVar and ClinGen, and some of us still get those confused, but ClinVar is ClinGen's partner. They're the intramural arm of the NIH. They're maintained by NCBI, and ClinVar views themselves as a public archive of the aggregate reports of variants and their relationship to human disease. It's a submitter-driven resource. ClinVar doesn't classify the variants themselves. They just aggregate and display the submissions from our colleagues from around the world. ClinGen, on the other hand, as I mentioned, it's an extramurally funded program. Heidi and her team and others do a lot to encourage and facilitate data submission to ClinVar. ClinVar data then is an integral part of ClinGen's curation. And ClinGen continues to provide feedback to ClinVar to improve usability, help make submission easier, et cetera. I'm just going to skip this slide, just giving you a sense that ClinGen has seen a tremendous growth in the past 10 years or so, where there's over 2.4 million submissions from 2,300 submitters worldwide. Another important part of the data sharing enterprise in ClinGen is not just working with the clinical testing labs that are sharing their data with ClinVar, but working with the participant and patient community. So ClinGen has a patient portal called Genome Connect, and this is an opportunity for research participants or patients who have received genetic testing reports to go through a consent process to agree to upload their genetic reports, provide additional information on the condition that they were being tested for, and then share the curated variants with ClinVar. And this has been a really incredible addition. There's been new variants that haven't otherwise been reported to ClinVar from the testing labs that have come from Genome Connect. And again, it's a great way to ensure that we're engaging patients and research participants in this data sharing enterprise. And I'm not going to show you all the different kinds of curation results, but I'm just highlighting one. This is ClinGen's variant curation results. There's this statistics page on the website that I find really helpful. So this is just showing you the update on the variant pathogenicity classification. So there's over 4,500 of those that are available and have been submitted to ClinVar. On the bottom, you can see in the small circles, this gives you a sense of the different types of expert panels that are working. For example, the CDH1 gene, there's the cardiomyopathy expert panel, and they are then curating the individual variants for the relevant genes for those conditions or that particular gene. The curated results make their way to ClinVar. They show up as a 3-star review status. And I just wanted to acknowledge that ClinGen is the first FDA-recognized public genetic variant database. And the idea that the FDA had with this program was that they wanted to help reduce some of the barriers for genetic test developers when they're seeking approval for their tests, so they can point to the ClinVar, ClinGen classified expert variants as part of their evidence submission to the FDA. And then switching gears now to talk about another resource, the Phoenix Toolkit. Just check my time. So Phoenix isn't a data resource. Instead, this is a catalog of standard consensus protocols that you can use for capturing information about your research participants. And the reason I bring this up, we're talking a lot about data integration, integrating data from across sites. And it's much easier to do that when you have information captured in the same or very similar way across your study sites or your various institutions. So that was the intent of Phoenix when we started this about, 12, 13 years ago. Phoenix has funding from over 7 other NIH institutes now. The PI is Carol Hamilton, so I'll just spend a little time walking you through it. So again, the idea is that this is a repository of protocols that you can use to capture phenotypic and environmental exposure information on your participants. There's over 900 protocols from 30 different research domains. The domains cover demographics, physical activity, thinking about different life stages from reproductive health through pediatric development and geriatrics, specific diseases, diabetes, cardiovascular disease, et cetera. And then we've partnered with other NIH institutes to do deeper dives into certain areas, so there's specialty collections. One of the more recent collections that I'll mention in a moment is social determinants of health. NIMHD worked really closely with us to think about what are some of the key measures for social determinants of health that we can encourage our research colleagues to use moving forward. And this is just one example. So, if you're a researcher interested in measuring nicotine dependence, you don't know how exactly would be the best way to do that, you could come to the toolkit and find out that the Fagerstrom Index is something that's recommended. So you have all sorts of information in the toolkit about how to administer that protocol, what are the standards, how can you link it with other resources. Phoenix has links out to standards such as LOINC. It's represented in the NIH Common Data Element Repository. And then there are opportunities to help ingest data into your Phoenix protocols into your research studies through vehicles like REDCap. Another interesting application of Phoenix is that the Phoenix team mapped all of the DBGAP studies. So last I checked, it was over 1,000 studies all of the variables in this DBGAP studies to the Phoenix variables. So now you've got this really terrific reference set. So, if you're interested, for example, in looking in DBGAP for all the studies that use a particular measure of substance use, you can search on that measure and then get a return. In this case, I just put in a search for which studies used alcohol 30-day quantity and frequency, and then got a return to find all the studies in DBGAP. So it's really helpful if you're thinking about wanting to combine and analyze data moving forward. And then I just wanted to say another word about social determinants of health. I was really glad to hear many of you bring up the importance of social determinants of health in our research studies, especially in the context of the genomics research that we fund. We recognize that we really need to spend more time capturing this important information and including it in our analyses and helping understand whether or not there is what contributions are from genetics and what contributions are from other factors like social determinants of health, which I'm guessing are quite high in most cases. So in the Phoenix Toolkit, as I mentioned, we have a new collection of these social determinants of health measures, both at the individual level and the structural level. I think there's about 30 standard protocols now in the toolkit. So for example, at the individual level, if you want to capture information about discrimination in healthcare or food insecurity, internet access, et cetera, and at the structural, or sometimes called the community level, using approaches to get at air quality, concentrated poverty, food swamps, et cetera. So I think it's a really useful resource. I encourage a lot of you to think about adding SDOH measures to your next wave of participant collection if feasible for you. And then I wanted to close by talking about a new program that we are spearheading in Multiomics for Health and Disease. In our strategic vision that I mentioned, we have highlighted some compelling genomic research projects. They're ranging from sort of at the very early level of in understanding and developing sort of comprehensive catalogs of the roles and relationships of genes and regulatory elements and pathways and networks, all the way down to, again, thinking about developing genomic learning healthcare systems for clinical care. But two of these compelling project ideas, one of which is designing studies that include diverse ancestral populations to enable scientific discoveries in genomic medicine for all, and then the second is extending multiomic studies of human health and disease into clinical settings. So with those two ideas in mind, we were marching forward with this new program in multiomics. We all recognize that advances in high throughput technologies have really increased our access to distinct molecular data types or omics data. I'm just showing you the kind of the top 5 on this slide here. We recognize that there are potential benefits of integrating this multiomics data. We've added the environmental exposures data on the left, including social determinants of health. The idea is that the potential for integrative multiomics in disease subtyping or identifying biomarkers, molecular profiles, unraveling biological networks, and drug discovery are just a few examples. And then I'm just showing you a pretty straightforward example on the slide here from Lee et al. To paper from JAMA in 2018, where the integration of multiomics data sets was used to better classify COPD, which can be helpful when thinking about therapeutic approaches moving forward. So, sort of what we're envisioning is that we'll be able to integrate the multiomics data and then start to have a better understanding of how the combination of all this information, we can use it to better understand transitions, for example, from healthy states to disease states, or perhaps conditions like asthma where you may have flare-ups, and get a better sense of if multiomics can be used as to help predict those flare-ups or better understand how to treat those flare-ups. So this is our new consortium. We have, this will be funded through a couple of RFAs. The applications have already been received. But the idea is for disease study sites to enroll upwards of 300 to 400 participants, capture information on social determinants of health, which I mentioned before using the Phoenix Toolkit, generating the omics data, at least 5 types of omics data at our omics production sites, and then integrating all of that data through our Data Analysis and Coordinating Center. And what we want to achieve at NHGRI is really developing these generalized approaches, ways to better integrate the data, best practices for analyzing the data, and then making these multi-dimensional data sets available to all of you through our Anvil data sharing platform. And I'll just close by talking about some of the diversity goals in this program. We've heard about how incredibly important it is to ensure that we have diverse ancestries represented in our genomics research effort. So the expectation for this program is that each of the applicants have to be able to demonstrate they can enroll 75% of individuals from racial and ethnic communities that are expected to have underrepresented genetic ancestries, establish the appropriate recruitment and retention strategies, and then also to assemble diverse study teams. So it's not just about enrolling the research participants from diverse communities, but also establishing teams at our institutions that reflect the diversity of our communities. And again, this consortium kicks off in 2023. I will stop here. I'm just throwing up a slide. We have a resource at NHGRIgenome.gov on accomplishments in genomic medicine. We just published a paper. We do this every year now, I think for the past 4 years, where we pick 10 of the top advances that we think are relevant in genomic medicine, and then we summarize those in our yearly paper. So I'll just include this up if you're interested and want to check it out. So thank you very much for your time. I'll close by acknowledging my colleagues in our division and also many of you that work on our large efforts that I described today. Thank you so much.